So there's only one chemistry chapter we're going to cover, and we're not going in, as depth as a chemistry class would go in. We mainly going to talk about chemistry of life. That means we're going to only talk about maybe carbon, nitrogen, oxygen, things that are important for life. So that's what we're going to focus on in this chapter. So first thing we have is the atom. We already learned the definition of an atom. It's a fundamental building block of matter. So that's the smallest unit that we learned so far. And then all substances, they consist of atoms. Now, so this is an atom, and it's going to have subatomic particles. Those are called protons, neutrons, and electrons. And sub means under or smaller. So they're smaller than basically the whole atom. So atoms consist of electrons moving around the nucleus. You see the word nucleus again here. And like I said before, nucleus just means a center. In the center, you have protons and neutrons. So proton, you can see a positive charge there. Think of P maybe as a positive. Neutron doesn't have a charge, it's neutral. Electrons have a negative charge. Now, this is for educational purposes. When they started giving these symbols to maybe protons and electrons, they could have given positive to electron, negative to proton. So these are for study purposes. It doesn't mean that's, that's the charge or that's true. So basically they, if they would have done that, we had to go back and change all the textbooks. But for now, I want you to learn that electrons are considered negative and protons are positive. So we have electrons, negatively charged subatomic, again, smaller particle that occupies the orbitals around the atomic nucleus. So it's going around. And on this picture, you see it's going around in a circle, exact, circle. Sometimes it goes around in a pear shape. So this is not always true. People who took chemistry or taking chemistry, they know this. Charge, it's an electrical property of some subatomic particles. Opposite charges attract. We have a proton here that's positively charged. We have an electron here that's negatively charged. If you think about this as a solar system, Earth is going around the sun. This is attracted to this proton and it's going around that nucleus, basically the center. Earth is going around again because of gravity, but here we have different reasons. So there is a nucleus and it's going around because the negative is attracted to positive, opposite charges attract, and the like charges repel. So negative is going to repel the negative. So some terminology: nucleus, core, or the center, and it's going to contain protons and neutrons. Protons are going to be positively charged. P, pro, means positive, positively charged, found in the nucleus, going to be in the center. Neutrons, they are neutral, there's no charge to them, and they give the atom a weight. So if you have more, if there's more neutrons, the heavier it's going to be. Here, this is a nugget of gold. On this picture, you see pure gold here. And if it's a pure substance, it's called element. So that's an element. The symbol for gold is Au. These symbols come from Greek or Latin names. I don't know what it means in Latin or Greek, but that's where the symbol comes from. And this is the atomic number, 79. Hydrogen has atomic number of 1. Helium has 2. So you continue increasing it in number and you get to 79. That's gold. And if it's pure element or pure substance, that's going to be called an element that consists of only atoms with the same number of protons. Here in this picture, this is a table salt. This is not pure element because you have two, you have sodium and you have chloride. Here it's just gold. So this is not an element. So this is for comparison. Have anybody, you guys been to Griffith's Observatory in Los Angeles? Anybody been there?
Yes.
Did you see the periodic table they have, Scott?
It's
yes,
huge.
it's pretty cool.
Yeah.
I think it's the coolest thing I've seen. So if you go to maybe Disneyland, this would be a good trip. I think it was also in some movies. I think it's temporary closed right now. Yes, temporary closed. So that's what it looks like. I'll show you the periodic table. So they have these boxes on the wall, and in those boxes, you can find all the atoms or elements that exist in the universe, basically. So whatever we have found so far, you can see them there. So it's pretty cool. Except the radioactive stuff. So they don't have the radioactive stuff. So I think you should definitely go there maybe next time you go to Disneyland or something. So you're able to see all the elements that exist in the universe, which is pretty cool. I think we go up to 150 or something. So atomic number, it's the number of protons in the atomic nucleus. Hydrogen has atomic number of 1. Helium has atomic number of 2. Carbon has atomic number of 6. And I said it's going to, the protons and neutrons are going to give it the weight. So atomic mass is 12 here. If we go back here, if we're saying their atomic number is 6, that's number of protons there. And if we go back here, there's protons, but there's also neutrons. If there's 6 protons, there's 6 neutrons there. That's gonna be total weight. That's 12 for carbon here. So that's going to determine the atomic number is going to determine the element. So if it's 1, it's hydrogen again. 6, it's going to be carbon. So here, atomic number is number of protons. Atomic mass is number of protons plus neutrons. So it's going to be double here. This is a periodic table. If you were in the classroom, we will have this on the wall. And you're going to notice, so hydrogen is 1, helium is 2, and then you have lithium 3, and it's whole numbers, 5, 6, 7, 8. You know, it's not half numbers. You don't see any 2.5, 1.5, or 3.5. And it goes, I believe goes up to, I think, 120, 150. So you have whole numbers, and sometimes when they use this hadron collider, they break down these atoms or elements, and there is some maybe different type of element that might exist just for milliseconds. So it doesn't really exist in the universe, but it might happen when they smash these atoms. But everything that we have found so far is here, and that's what you can see if you go to LA to the observatory. You can see actually each element there. I think that's really, really cool. So here we have the mass number on top. And this is important because if I give you this picture and you won't have this there, and I might ask you, what's the mass number? I don't want you to confuse the mass number with atomic number. So make sure you know that's on top. Atomic is here as the element, and this is the element name, that's carbon. So all the living things are made of carbon, coal is made of carbon, diamonds are made of carbon, depending on how they're arranged, basically. So everything that's inside you, basically, the backbones of carbohydrates and all that's made of carbon. So like I said, we're gonna talk about the elements or atoms that are important for life. So carbon, nitrogen, oxygen, maybe water. So those are the ones we're going to discuss. So carbon atoms are found in greater proportions made by living things. Oh, there's a question. The atomic weight of nitrogen is very near 14, indicating most nitrogen atoms have mass number 14. How many neutrons does the average nitrogen atom have?